Today we start with a new packet. We're on the yellow packet, and today's lesson is exponential functions. Your homework is on page 4 in this yellow packet, and I'll give you a minute or two to write down the definition of an exponential function. The exponential function f with base a is f of x equals a to the x, where a is greater than 0, meaning it cannot be 0 or negative. A is also not equal to 1, and x is all real numbers. A, the base, cannot be 1 because 1 raised to any power is still going to be 1. And a is never going to be negative. Our base is never going to be negative. We have examples of exponential functions. We could look at the ones in blue. And given what we just said about the base, a, in f of x equals 2 raised to the x, 2 is the base, so it can be an integer. G of x equals 1/2 raised to the x. So we can have a fraction as a base a, and h of x equals 0.178. So we can also have a decimal as a base. Please then, after you copy them down, take note of the functions in green, k of x, w of x, and z of x, and what do you notice? What I see is that the exponent is a number. It is not x. So one of the deciding features of our exponential function is that the exponent must always be x. Okay, please go down to the middle of your page, and we'll talk about our graphs of exponential functions. The graphs of all exponential functions have similar characteristics. So starting with example 1 on the left, we have the graph of f of x equals 2 of x, and the graph of g of x equals 4 raised to the x. So again, they're both exponential because they're raised to the x power. What differentiates them is the base a. So we've got 2 and 4. And what you'll notice when we do the graph is that that base a determines the steepness of our curve. So you're going to plug those functions into your calculator. So y1 will be 2 raised to the x. y2 in our calculator will be 4 raised to the x. And then you can call up the table where we can get all of our x and y values. So when f of x is -2, we have 1/4. Because of course, 2 raised to the x, and x is -2, is 2 to the -2 power, which is the same thing as saying 1 over 2 squared, which is 1/4. Raised to the -1/2, raised to the -1, our y value would be 1/2. Raised to the 0, anything raised to the 0 power is 1. 2 raised to the first power is 2. 2 raised to the second power is 4, and 2 raised to the third power is 8. So we're able to do our first graph. We'll start with 0, 1, 1, 2, and 2, 4, And then over to the left of the y-axis, we've got 1/2. And of course, we'll have 1/4. If we do our function g of x, so 4 raised to the x power, when we put -2 into our table, we get 1/8. -1 gives a y value of 1/4. Anything raised to the 0 power is 1. 4 squared is 16. I'm sorry, is that right? Yeah, 4 squared is 16. Oh, I'm sorry, that was 4 raised to the first power. That's why I was so confused. And then 4 squared is 16. And 4 cubed, I believe, is 48? No. Yeah, I think it's 48. No, it's 64. So graphing our g of x function. Starting over here at -2, we're at 1/8. We're at 1/4. 0, 1, so they share that point. 1, 4. And that's about as far as we're going to be able to go. So drawing our g of x. That wasn't so great. Let me try again. We can see that g of x is steeper than our first function f of x, 2 raised to the x power. So going over our domain and range for both functions, anytime we have a raised to the x, and in this case a is an integer greater than 1. So our domain is going to be all real numbers. It'll go from -infinity to +infinity. Now, our range is very important here. If you look very carefully, you can see that we have an asymptote. We have an asymptote here at y equals 0. Our functions, neither f of x or g of x, are going to go below y equals 0. So if we're talking about our range, we're going to have a parentheses because it's never going to touch that asymptote. And then our lowest y value is greater than 0 and goes to +infinity. Our intercept. So if we're talking about our intercept, it can be our y or x intercept. If it never touches our asymptote, y equals 0, there's not going to be any x-intercepts. There's only going to be a y-intercept. And that y-intercept is where x is 0. So if x is 0, we can look above and see our y value is 1. As we look to see if our function is increasing or decreasing, we are looking from left to right on our graph. And we can see that we have an increasing function. Our asymptote, as we discussed, since our function will never touch or dip below the x-axis, it's y equals 0. And the function is continuous. There are no breaks or holes or anything in our function. So we can say, yes, these exponential functions are continuous. Moving down to our functions f of x and g of x below. This time we have fractions raised to the x power. Both f of x is 1/2 raised to the x power, and g of x is 1/4 raised to the x power. So again, we're going to put in y1 in our calculator. 1/2 raised to the x, y2 raised to I'm sorry, y2 equals 1/4 raised to the x power. So this time, when we take a fraction and raise it to a negative exponent, that flips the fraction. So 1/2 raised to the -3 is the same thing as saying 2 to the positive third power. We're going to end up with 8. 1/2 raised to the -2 is the same thing as 2 squared, 4. 1/2 to the -1 is going to make our y value 2. Anything raised to the 0 power is 1. 1/2 to the 1 power is 1/2. 1/2 raised to the second power is 1/4. So we're now on one color, on my brown color. I'm going to graph this before I switch to our g of x function. So when I have -1, I have 2. When I have 0, the y value is 1. At 1, it's 1/2. And then at 2, it's 1/4. This is our f of x function. So g of x is 1/4 raised to the power. If I have 1/4 raised to the -3rd, it's the same thing as saying 4 raised to the 3rd power, so that's going to be 64. Then I'm going to have 16, because 1/4 raised to the -2 is 4 squared. 1/4 raised to the -1 is going to be 4. Anything, including 1/4 raised to the 0, is 1. 1/4 raised to the 1 power is 1/4. 1/4 raised to 2, the second power, is going to be 1/16. So, quickly graphing our function. At -1, I have 4. And at 0, again, I have 1. At 1, I have 1/4. And then at 2, I have 1/16, which is very close to the y equals 0, or our x-axis. So now I've just graphed g of x. And you can see that g of x is steeper because it's 1/4 raised to that power. So talking about domain again, it's still all real numbers, -infinity to +infinity. Our range, again, we're looking at an asymptote. Our asymptote is still at y equals 0. So our lowest value is going to be 0, but it's not going to be touching that x-axis. So 0 to +infinity. Because there's an asymptote at y equals 0, there is no x-intercept, only a y-intercept. So when x is 0, y is 1. This time we have a decreasing function. As we go from left to right, we can see that the y values are getting smaller and smaller, makes it a decreasing function. Y equals 0 is our asymptote we just discussed, and our function is continuous. Because some of our functions are not going to look exactly like our lesson when you do your homework, keep in mind that the parent function for every exponential looks like this, where this would be the y-intercept. And then if we're talking about a function that is transformed, keep in mind that it's going to be a raised to the x minus h plus k. H moves the function left and right. K moves the function up and down. Your homework is on page 4, and we'll see you tomorrow.